Welcome to the world of mathematics. Today we will discuss another remark. What does this remark states? Let's see. It says if the order of this vector V is 1 by n and the order of matrix A is n by m. Okay, then the product of V and A, okay, is m times 2n minus 1. Okay, so before proving this I would like to give you some explanation that might be helpful to understand you this theorem, okay, this remark actually. So for example, if I have vector, this is V vector I have, for example, and the matrix that I am taking is the is the it has 3 rows and n columns. Okay, the order of this vector v1 is basically what it has, what 1 row and n column, and the order of this matrix A is basically it has what, how many rows it has, it has 3 rows and it has n column. Okay, then the product of AB would be what, if you see, when you multiply this thing with first row, okay, you will get R1 S1 plus R2 S2. So you can rewrite this one in the summation form. So I have written this whole product into the summation form to make our work easy, right? Now remember from the remark 1, when we multiply this vector by when we multiply this row by column, our cost is what? Our cost is basically 2n minus 1. Okay, so how many such vectors are there? There are such a 3 vector. Now count here, there are 1 2 3. So we have such a 3 vector. So we add this cost 3 times. Okay, so we add 3 times this cost. Okay, let me write it. Okay, so we write this cost 3 times. So the 1 time, 2 time, 3 time. Okay, this one for this one, and this one for this one, and this one for this one. Okay, so when you add these 3, what do you get? You get 3 times 2n minus 1, right? Now let me give another example similar to this one. For example, if you have the same vector v1, v2 all the way up to the vn, and now in this time I am taking the vector, I am taking the matrix A, whose order is what? Let me write the order first of this one. It has 1 row and n column, and the order of matrix A, it has 5 row and n columns. Okay, now you see here, when I multiply these two, A by V, or sorry, V by A, what do I get? I get these 5 summations. Okay, so these 5 summation you can see here. What I have to do, I have to just add. First of all, remember this one you have to multiply, and this one you will get R1 S1, R2 S2, all the way up to the Rn Sn. And when you multiply this R1 R2 up to the Rn with the T1 T2 up to the Tn, you get R1 T1 plus R2 T2 all the way up to the Tn. So I have written these things just in a short form, in the summation form. Now remember from the remark 1, when we multiply the row vector by column vector, our cost is basically 2n minus 1. Okay, so how many times this happens in this case? It happens 5 times. Okay, so basically what do we have to do? We have to add 5 times the cost of these things. Okay, so I have added here 5 times these cost. Okay, now you can see here, when I add 5 times these, so this 2n minus 1 is repeated 5 times. I have written that when I have the order of vector v1 is 1 by n, and the order of matrix A is 5 by n, then the cost of the product of VA is basically 5 times 2n minus 1. And the key point is that when you have a with how many rows? A with 5 rows, cost is same except this 5 that we are multiplying here. Okay, so it's a key point that you should keep in your mind. Now let me go to the next one. Now we are going to prove this. Okay, so to prove this, I am supposing that this V1 is a V1 V2 up to the R n. Okay, I mean this is a V and these are the R. Okay, its elements, the elements of vector, and the A matrix has the elements, that is I have supposed here S1 S2 all the way up to the Sn. Here the subscript is showing the elements and superscript is showing the column. Basically the first column, it shows the first column, makes my life easy to write in the summation form. It shows the second column. Okay, these are the elements of second column, and similarly these are elements of the mth column. Okay, now when I multiply these things, okay, what will happen? You can see here we will get these results. Okay, now what I am going to do, you can see here, remember from the last statements, then how many times I am adding here? I am adding here 2n minus 1. How many times I am adding here? I am adding here 2n minus 1 m times. Okay, I am adding m times, because how many columns we have, how many rows we have, how many columns we have m columns. Okay, so the thing is that we have we have what, we have m columns. Because we have m columns, that's why the cost of va would be what, the cost of va would be m times 2n minus 1. Maybe I have made a mistake in the here. Maybe let me see. It has how many rows? It has n rows, so I have made a mistake here. So let me correct it. It is a n rows and 5 column. Okay, and similarly I have made another mistake, that is it has what, it has how many rows, it has n rows and 3 columns. So sorry for that. I made this little mistake in first, second, and the last one I made my mistake correctly, because here I have written that the order of, let me write it, the order of V is equal to how many rows we have. We have one row and n column. Okay, and the order of matrix A here is what, it has what, it has n row. Okay, it has n rows and m column. Okay, now I am going well, good. Okay, so this is the course that we have proved here. That's all that we needed to prove. Now there is also another remark that we need to prove. It's quite easy, I think. I don't need to prove. It says there, remark 3 is that if the order of vector v1 is 1 by n, okay, and what, and the order of matrix A is n by n. That means if we have a square matrix, then the cost of AB is 2n square minus 1. Okay, it basically it follows from the remark 2 by putting m is equal to n. When you put m is equal to n, what do you get? In place of m, there were m, so we have put here n. When you multiply, you will get your result. So you have proved with this. I hope this is quite this is clear to you, and you can ask any question in the description below, in the comments, sorry, I mean in the comments. If you have any question, you can ask over there. Okay, thank you for this time.